First of all, thanks to Matkar for giving me this opportunity, and thanks to Mr. Tangian as well as Mr. Mukherjee. Last couple of days we have been talking about a lot of things about corrosion, coating, and my topic is a little bit different. I'll be talking about rotating equipments and mainly pumps and compressors. I'm glad that Mr. Datta yesterday mentioned about asset reliability, and my topic gets into the reliability of rotating equipments, in particular mechanical seals and supply systems. So my focus in this presentation will be on pipeline pumps, in particular crude oil as well as natural gas. I'm pretty sure all of you know this, so I won't go through each one of them. Different categories of pipelines, and we work with the gathering pipelines, transportation as well as the distribution. And different types, we work with, or the mechanical seals are used in gas, multi-phase, carbon dioxide, and crude oil. The challenge is very high when you deal with the multi-phase. We all know about it. And the challenge gets even higher if you have to handle liquid carbon dioxide. A simple layout of pipeline. I just took this picture from the Trans-Alaska pipeline. And as you can see, we come here. I'll try to show you. Here it is. This is the pump house or the pump station. And this is where you see the rotating equipments like pumps and compressors. And a much better picture here. You can see over here. And typically these pumping stations, you will see 2 or 3 pumps. One of them would be the standby. Different pump designs have been used depending on what you try to transport, what you try to pump. It could be something like a centrifugal pump to a positive displacement pump. And that is mainly desired by the viscosity of the fluid that you try to transport. This is the main topic from me for the day. There are several seals used in these pipeline applications. One of the reasons I've taken this topic for today is a lot of my experience have come from working with the pipelines in the Gulf Coast in the US, where I worked very closely with the companies like Enterprise, Sunoco, and Enbridge. It started like a small problem, and then after 3-4 years, like Mr. Krishnan was mentioning, it became a big specification where we have to work with some of the consultants like S&P, Jacobs, and other guys, so that we can avoid some of the accidents that are happening at the the pipeline, particularly in the pump houses. So to give an idea about the pipeline seals, you would see something like so simple here, where just for the clarification, let me give you a little more if you are not aware of these mechanical seals. So we really call it as a matured asset because most of these pumps are 25, 30 years old, and typically they are falling under API 610 7th edition or a 6th edition or 8th edition. Recently, now we have gone up to 11th edition, so I can't fit a seal that's really made for API 610 10th or 11th edition into a stuffing box or a pump that conforms to 6th or 7th. It's very tough, but there are some technologies available. So just to give an idea, this is how a simple mechanical seal would look like. There is a shaft. This is your pump stuffing box on this side, or the process fluid, and this is your atmospheric side. And you got 2 seals, primary and secondary. And the one in yellow is rotating, and one in blue is stationary. And the whole arrangement, how it looks like. In other words, there is a rotating phase, the stationary phase. A lot of the technology and innovation happens here because there is always a myth that many times customers ask me, can you give me a seal that doesn't leak? I just want to make sure 100% leak free. The answer is not possible. There is not a single seal in the world that's going to give you leak free. We can only arrest leakage or minimize leakage, because even for a mechanical seal to work, I need a fluid film between the 2 phases. If I don't have it, I'm going to generate a lot of heat. If I generate a lot of heat, I have to remove it. It gets more and more expensive. So it's important that we understand that every mechanical seal is designed to leak. The question is how much you want to leak. I mean, is it a drinking water or a cooling water, or is it a petrol, diesel, or is it a ethane or a propane? How much you can afford to leak, and as the environment higher. So now, to go back, just think about this, that a seal that is designed to be fitted in this such a big space has to be fitted to the 6th or 7th edition where the radial distance or radial gap is so small. So this had been the challenge in the recent times, and you can see here, this is the latest edition seal, and there is a new concept introduced. Here is the complete API 682 phase design, because when you talk about mechanical seal, it is the phase. The rest all are adaptive. Okay, so what happens is that how can you take this and then fit within the smallest stuffing box, either the 5th edition or 6th edition stuffing box. So the new technologies have been brought in where you can do that today. So which means there is no modification is required. Now just think about a pump house which has got a pump more than 20-25 years. There is no way you can remove the pump and then take it to a maintenance shop and then bore it another 2 to 3 millimeters and then fit a new seal. It's going to be next to impossible, because not every pump station has got a maintenance shop that well equipped at that place.
Sir, your time is running out.
Okay. So these are the seals, different types of seals. You could use a single seal up to 60 bar pressure, and as well as the same seal with a slight modification on the faces where you can introduce a hydro groove so that you can reduce the heat generation. You can go up to 90 bar. And these are the demanding and very challenging in the pipeline applications, because you talk about high pressures, very big shaft, high velocity. You talk about 3000 to 4000 RPM, and many times you need the reverse pressure capability. And sometimes you need to have the dry running possibility also, and high viscous like crude and volatile fluids like ethane. A lot of my experience was on ethane, and it is very funny because we took a lot of time to learn about how to seal ethane with really minimized leakage, because ethane moment it gets between the phases and comes to the environment, it becomes gas. So the challenge is whether you put a dry gas seal or whether you put a liquid seal. So we have come up with some new concept where we are able to address it, and a lot of other stuff. And one of the seals, this was in Dallas, Texas, where the pump house got fire, and like you mentioned, a lot of accidents. There were accidents, and these accidents mainly because of the fire at the pump station. I don't have exact details, but this is mainly because of the failure of the rotating equipment. There are different combinations available, like I said, single seal. And if you are sealing ethane, then probably you need to have a containment seal, which is a gaseous seal at the back. So this is the most, I would say, successful seals that have been applied in many pipeline applications, where you can see that 2 seals and huge, I would say, the construction. So you can have face-to-face or back-to-back, different configurations available. Many pump times. All of these are employed. I just skip through this, and this is how it looks like sometimes. The pump house, and most of them are split case, and something like what you have seen to this extent, where you're talking about twin screw or triple screw pumps for transporting or pumping the crude oils. The challenge here is the box is very small, and you can see how big it is. So I talked about these features and different API plans used. You can employ as simple as a tandem seal with a plan 52 to a double seal with the plan 53. And recent times, in the last 5-6 years, there is a lot of innovation happened on plan 53B, and which is also incorporated in API 682. In fact, API 682 went to the concept here. You can see that we have the seal, we have the system, all are completely integrated. Just to give an idea how big or how the system looks. So this is how the whole system looks. Just to keep your seal running, just to keep your system, mechanical seal properly having a, I would say, the healthy environment, you need to have something like this. I typically call this as a torpedo, because you have your accumulator, you have your reservoir. So it's a huge system. So a lot of opportunities. I'll just skip all of them, and I'll go to the last one.
Thank you.
So API has come with a lot of additions. This is the important thing for all of you, because whatever was happening in the pipeline application, all the issues that were going through, API finally said we need to include the pipeline application issues also part of the API 682. So last year API 682 released the 4th edition. You won't believe it, 4th edition mainly focuses on the pipeline applications, and there are several new piping plans have been introduced, like plan 55, 65A, because most of these are in remote locations, and you can put an orifice here, and you can see how much leakage is coming through, and then you can have a transmitter to transmit to your control room. And 65B, you can have a valve if the leakage is too much, and you can go with 66A. You can see there are two carbon bushes here. This acts like an orifice. And even in one of the pipeline applications, they put the orifice. These are again bushes only in the port itself. That's it.
Sir, thank you very much. I would request the audience